I'm Dr. Padilla. I'm a professor in computer science and psychology, and I study how people reason with data visualizations. On this channel, we talk about how to make better visualizations, some of the science behind how visualizations work, and we've been talking a little bit about these concepts of expressiveness and effectiveness. In service to that, I have been harping a little bit on the 3D pie chart, in part because it fails some of those basic evaluations. What is going on with the 3D pie chart is that the slice of the pie that is closest to the viewer will appear bigger than it is. That leads to incorrect interpretations, and in a sense, it is conveying information in the data set that is not there at all. So it is failing that expressiveness principle. So what do? We need some alternatives to pie charts. I'm going to talk about a few today. There's certainly more that I'm not going to discuss, but I will tell you about a few of my favorite techniques. Okay, let's begin with our simple pie chart here. I just want you to estimate the proportion of the gray part of the pie to the yellow part of the pie. Just take a second and do a little estimation here. Okay, maybe you got it right, maybe you got it wrong. In any case, I want to highlight, this is the data set we're going to work with, and I want to show you alternatives to representing the same data. Okay, so here's a whole sequence, and they're all using a very similar property, or rather than showing continuous proportions, they're showing discrete information. At the top, we have pictograms, and what I'm showing you here is we have a number of cloudy days to sunny days, and that can be represented with this data as well. We also have an isotype, and that is an acronym for International System of Typographic Picture Education. And it's represented the same way. Now, usually what these are is descriptions or alternatives to bar charts as well. So you can imagine a bar that covered this space and a bar that covers this space. Instead of a bar, we have pictures, icons, to represent the same information. Similarly, we have something called a waffle plot. In the waffle plot, what we have is usually squares or rectangles to represent the proportional information. And the difference between a waffle plot and some of these others is that usually waffle plots are created on a grid so that you can count up the number of squares very quickly across that grid. And then the last one is an icon array. Same concept as a waffle plot, but you can use icons. Now, these are all very similar. And people tend to use these terms interchangeably, which is why I'm putting all of them up here. They all have the same basic function, which is representing probability or proportion discretely rather than continuously. Now, what are the benefits of that? If you're representing this proportion discretely, it allows people to very easily count up the information that they're shown, rather than having to do either an area judgment to calculate this piece of the pie, or a angle judgment or an arc judgment. Those are three ways that people calculate the different portions of the pie. You simply count up the icons. It makes it very, very simple, which is why it is an excellent alternative to the pie chart. So what makes these so effective? There are dozens of studies that look at how people interpret what I'll call icon arrays, which is a kind of this grid of information here. And what we tend to see is that people, even with low levels of numeracy, which is the inability to understand numbers effectively, can easily and accurately interpret these types of information. In comparison to any other representation, these are very, very effective. The really cool part about the research that's done in this field is often it's done in a healthcare context. And in a healthcare context, they have to use clinical trials. So many of these visualizations have been validated with clinical trials with real patients interpreting real health data across thousands and thousands of participants. That makes it a very stable and reliable technique, especially if you're looking at someone from the general public that may not have advanced understanding of graphics or numbers. What we have in this visualization here is we are shown two different grids. One is the success rate of balloon angioplasty, and the other one is the success rate of bypass surgery. And the darker icons represent successful cures versus the non-successful ones that are grayed out. And this is a very, very common way of expressing this information, where you have a colored version and a grayed out version to indicate the opposite of whatever the colored case is. So let's look at a really amazing example that illustrates the power of this technique. This was actually one of the winners of the Data is Beautiful contest, and it is an interactive waffle plot. And what this is showing is this blue rectangle contains the overall sum of goods and services produced in Brazil. the GDP. And what is going to happen is we're going to start to get a waffle plot that fills up this entire sum. This is illustrating how much the federal public debt was in 2020 with these little icons here. Each of the yellow icons represents 5 trillion. And it starts to fill in the information to show you the proportional relations. Now we're seeing how much it costs in terms of interest. As we scroll down here, we have how much does this debt actually earn. The same period, we're looking at 1.5 trillion of the debt stocks matured. Now we're looking at how much you had to pay. Of this, 200,000 billion were paid with budget resources. And the majority, however, was refinanced. Now, you can go through this and look at the different elements that are adding up to teach you how to understand the proportion of debt in Brazil, which is really amazing. And then it re-breaks down this information to look at the proportions for federal institutions, investment funds, pensions, etc. So this is a really lovely example of how to take these proportional probabilities and break it into very easily digestible information for the general public in such a way where you can understand the elements that contribute to these different proportions. Now, of course, you could do the same thing with the pie chart and show the different proportions of the pie growing or shrinking, but there is something really special about having discrete information that is being stacked or added up. Here's another way to compare it, and what I want to highlight here is by representing the data in these two different ways, it conveys a different sense about the actual information. Here we have a pie chart illustrating the GOP versus Democrats, and here we have an icon array, and this is organized based on the different electoral seats. What is happening is each one of these dots represents an individual person. And what we can start to do when we have these discrete visualizations like this is we start to humanize the data by allowing people to start to think of these dots as individual people, not abstract information. We have the exact same information here as here, but all of a sudden we're starting to think about the individual people that are contributing to these data. I want to show you another example that really humanizes the data using these discrete encodings. Okay, this is probably one of the cutest visualizations you're going to see. It is by the New York Times. And what they have here is these little icon arrays of people that are representing the different state. Now, what makes this cute is they're little human icons, but they're also animated to illustrate emotion. These guys are kind of sad or upset, and these ones are happy. And it does this across these different types of information that they're trying to convey in the story. When you start to see information described in this way, you don't necessarily think of it as raw, abstract information. You're connecting it to individual people and their emotions and their outcomes, etc. But it still functions in the same way. What you can do is count up the different states that could vote versus those that couldn't vote, both from Republican and Democrat in these cases. Okay, so that was very fun. I'm sure you're starting to see ways that you can communicate proportions by using icons. I want to show you one more example that illustrates how it can work very effectively, but also some things that you want to be cautious about. Here we have a visualization from 538, and it's illustrating gun deaths in America. One of the major differences between the visualizations I've shown you in the past and this one here is the number of individual icons that are being represented. We have each dot here, which is representing one gun death, and we have more than 30,000 of these individual dots. So as we click on this, it's going to walk us through some statistics. It's going to show us proportions of people who were shot in police violence or criminals. We're going to look at proportions of gun deaths from suicide. We're going to look at how more than 85% of suicide victims were male. Of those men, they were 45 years or older, etc. So it is showing us these individual proportions with these teeny tiny dots, which is great. And I think the important part of this is we're talking about a subject matter which is very important to humanize. We are looking at individual gun deaths here. Okay, so very, very effective. If I go all the way to the end of this, to the explore yourself, one of the amazing parts of this is you can actually ask different questions. You can look at individuals who identify as female, particular ages, and particular races, for example. which is really great. So this is a wonderful visualization. But what it does not do, and what can be challenging with these types of icon arrays, is having a situation where you have a sufficiently large data set that will be too large to count. This data set is too large to count. If I have a larger number here, I am not counting up these individual dots. You could count them in theory. I am not going to do this. Your viewer is not going to do this. So what they've done very cleverly here is they've summarized this information so you don't have to count up the individual dots. So if you're working with a data set and you're going to represent thousands of individual dots, be aware that people are not going to be counting them up. What you can do is think about putting them in a grid where people can approximate. So if these were in 10 or 100 increments, we could count up hundreds, for example. We could say 100, 200, 300, etc. But don't expect people to individually count. So that's one of my cautionary suggestions, is if you are going to use these icon versions, be cautious of the number that you're going to use. If it's a sufficiently large number, you're going to want to give people support so they do not have to individually count this information. There's other caveats as well. These truly have the same issue as pie charts. Most of the real problem with pie charts is that you have so much information that's being represented and they become too cluttered and you can't look up all of this. This is just a fictional one that I made here. Same thing can happen with any type of icon array. If you just have too much information, it's going to make it impossible to look up. So in both cases, this icon array is not going to solve the problem of presenting too much information all at once. My closing recommendation is, if you need to represent a large number of categories, either with an icon array or this pie chart, consider combining it with another technique called small multiples. Here's a great example of small multiples from PolicyViz, which is a great resource if you want some more in-depth information about how to visualize your data effectively. But what they have going on here is they're using small multiples and a waffle chart together. And this is an interactive template that they've created in Excel. And I bring this up because oftentimes we think of Excel as maybe not being as dynamic as other types of visualization software, but it absolutely can be. And there's lots of resources out there for you to make it more interactive and dynamic. The main point is that we have these waffle plots here that you can easily and quickly count up the information. And it's broken down into a technique called small multiples, where you're representing different data in individual frames of the plot, rather than combining them all into one mega waffle plot, which you could do with all of this data. They've broken it out so you can see the relationships of the individual categories. And that is a very technique broadly, independent of waffle plots or pie charts. Small multiples can be very, very effective if you have a large number of categories that you need to represent. That's all for my alternatives to the pie chart. There are many more. Comment down below with your favorite if you have other ones that you particularly like. I happen to like these because they have a great deal of empirical work that suggests that they are very effective, particularly with people who have low numeracy, particularly with health information, and they're easy and effective to read. They also tend to be more memorable depending on the types of icons that you use. So lots of evidence that they're effective, but certainly there's not a one-size-fits-all solution. You should think deeply about your use case to determine if they are right for you in your situation. I've shown you lots of examples, and all of the links to these individual visualizations and the templates will be in the description below. If you have more questions about data visualization or there's topics you'd like me to cover, please also comment down below and I'll do my best to cover those techniques. I hope this was helpful and you can find better alternatives to the pie chart. Take care.